Hey guys, this is Mr. Waltz. I'm going to show you how to make circuit 9, which is the diode circuit. So I'm just going to duplicate circuit 8, use that as my starting point, and can go in here. The power supply is fine. Don't need the photocell anymore. We can get rid of our jumpers. We'll keep that LED, and we're going to need a couple of resistors. So I'm going to put my resistors in here. I'll put one in row 2. Boom, and then that needs to be 330 ohms. Boom, there we go. And then we're going to find a diode. You got to scroll down here a little bit. You can see the diodes. So on these diodes, the way they're supposed to work is the positive side has no stripe. The silver stripe is the negative side. So we get our positive power coming into row 2. So that's where we're going to put the top of our diode. And then the diode here, the negative side, is going to feed our LED. So we can throw our LED into rows 6 and 7. And then we need to provide a connection for the negative side of the LED. So we'll just put a jumper here from 7A over to our negative rail. And so now we have that first part of the circuit wired up. And then the second part of the circuit, it's a parallel circuit with 2 branches. It's identical, except we're going to reverse the orientation of the diode. So I'll go down, I'll start this in row 9, leave a little space in there, Control-C for copy, Control-V as in Victor to paste, place my resistor, copy my diode, oops, I'm going to go Control-C, Control-V, put that in rows 9 and 13. And on this one, we're going to reverse the diode just to see what happens. So we'll go Shift-R, till it's upside down, and then we'll drop it in there in 9 and 13. So notice the silver stripes on the top, that's the big difference. Then we can copy our LED, paste that, drop it in here at 13 and 14. And I'm going to go ahead and change the color on that. We'll use yellow, we'll be all Panther Pride here. And then row 14, we're going to go to negative to hook that back up. So now you got 2 LEDs, each got their own resistor, they each got their own diode. And we're going to start the simulation here and see what happens, okay? So we start the simulation, and you can see we got 19.1 milliamps, and only one of our LEDs turns on. And so the reason for this is the diode. So in this case, the top diode, we got the silver side on the bottom. So the anode is connected to positive, and the cathode is connected to negative, and the silver stripe there shows you the cathode. So when you connect these in this way, as long as you have enough voltage, they'll turn on. Now, another thing about a diode is it has a minimum voltage required to conduct. It's a semiconductor material inside. So if there's not enough voltage, it actually becomes an insulator. So let's turn the voltage down here, and we can see at a certain point, it should turn off the LED. And there you go, at 800 millivolts, it starts to turn off. Let's try 1.0. 1.0, I got nothing. 1.2, 1.4, 1.6. 1.6, it turns on, okay? So that's the minimum voltage required to get that diode to conduct. So I'll set the voltage back to 9, and then let's see if we can fix it. So to fix it, what we got to do is change this diode. So it's blocking the current here. Current cannot flow through it in the other direction. And that's what we use these for usually is we have a situation where a component can be damaged, or we just don't want our circuit to work correctly. Like say you want to have a motor that only goes one way, something like that. You can use the diode to prevent it from going the opposite way. So we're just going to take that diode and do some Shift-Rs here until it's upside down, silver's on the bottom, plug it back in, and we'll fire this bad boy up. And you can see now both of them light up. They got 38.3. Now, I don't know if you guys remember, but we had about 42 milliamps before when we were just doing one LED, or the parallel LEDs. So they each consume about 21. So 21 times 2 is 42. So we're missing a little bit of amps. So we do have the circuit working now, but let's investigate where our missing amps are going. And to do that, we can use the meter. And what I'm going to do is measure the voltage across the LED, or sorry, the plain diode. So I'll go off this first diode here. I'm going to go in there, put a red probe on it, boom. And then I'll go to the bottom of it there, boom, and we'll do the black wire. Okay, we got this set to voltage. Let's fire this bad boy up. And you see here that our power supply voltage is 9, but the diode is consuming 611 millivolts, and that's 0.6 of a volt. So that's the cost of having that diode, is it eats up a little bit of your voltage. So this LED, instead of getting 9 volts minus the resistor, it now gets 9 volts minus the resistor voltage minus the diode voltage. So it's getting fed just a little bit less voltage, and therefore it's got a little bit less current.